So in this video we are going to see what is subnetting and how to do it. But before we begin, let's say we have an organization that requires internet connectivity, and let me just draw this internet cloud, and let's say that we have a WAN link which is connected to a router, and this router belongs to our organization. This is the WAN link, and let's say that this router is connected with a firewall because we need to protect our network. This is the firewall sign. Let me just write it as well, and say that this firewall is connected with a switch, which in turn is providing connectivity to our servers. For example, this could be an email server, this could be a web server, www, and we have, let's say, another third server which is, say, database server. Besides that, this firewall has two other interfaces connected with two routers, and these two routers could be providing connectivity to other parts of the organization. For example, this could be finance or this could be production, and let's say we have 20 hosts over here and we have, say, 50 hosts over here. This is the network, and can you count the number of networks that we have over here? Remember that routers break the network boundaries. So we'll have one network over here and other network over here, a third one between the firewall and router interface, a fourth one between this interface of the firewall and router, a fifth one over here, and a sixth one over here. Now you approach INA, or as we write it, IANA, which is Internet Assigned Numbers Authority, and responsible for allocation of IP addresses. So you ask them to give you a network address, and they say, sure, no problem, here it is. And they give you, let's say, 136.11.0.0 with a subnet mask of 16 because it's a class B IP address. So when you see your network, you ask yourself, how can I distribute that one network into 6 places? Because you cannot simply assign some IP addresses to one portion of the network and some other to another portion. Why? Because then this router will say that I can reach to these IPs, while the other router will be saying the same thing, because the network and the subnet mask portion is the same. But you can divide the network by using subnetting technique, and you can do that by borrowing some bits from the host portion. So for example, we have this 136.11.0.0/16. we have this network. Now first of all, you need to know that how many networks do you need. The example that we have seen, we need 6 networks. The next thing you need to know that how many bits will cover this digit 6. So we know that if we have 1 bit, we have two possible combination, either 1 or 0, right? If we have 2, then we can have 4 combinations. If we have 3 bits, we can have 8 combinations. So 6 will be covered by 3 bits. So we need to borrow 3 bits from the host portion. But how to take those bits? For that, write down this IP address in binary. But we do not need to write whole IP address. We are simply concerned with the host portion. So the third and fourth octet will be 136. Let's say first and second will remain the same because we cannot borrow any bits from here. We can only borrow bits from the host portion. And we write down the host portion as, let's say, 6, 7, 8 bits of third octet and 8 bits of the fourth octet. And now it is important to remember that once you need to do subnetting, you start borrowing bits from the left side, like from here, and they have to be in continuous order. So we can borrow bits this one, since we need 3, this one and this one. They have to be starting from the left side and in consecutive order. So once we have borrowed these bits, our network mask, which was earlier 255.255.0.0 because 16 means this, now we have borrowed 3 bits, it will become 255.255. What? This 128, then 192, then 224. So it will become 224.0. So now that we have a subnet mask with 3 borrowed bits, we can define the networks. First network will be, let me write it over here. First network will be 111. My mistake, sorry. Just let me rub it. So first network will be 136.11.0.0, and now we do not write 16 because we have borrowed 3 bits, so we write down 19. What about second network? To know the networks, that what will be the second network, we simply divide, not divide, rather we simply subtract the subnetted portion of the subnet mask from 256. So over here, since we have borrowed 3 bits, which comes out to be 224, we subtract 224 from 256 and we get 32. So this 32 means that the step size or the difference in the networks will be of this much. So the second network will be 136.11.32.0/19. Third one will be 64.0. Then we'll have 96.0. Then 128.0. Then we will have 160.0. After that 192.0, and lastly 224.0. and if you count them, these will be 1, 2, 3, 4, 5, 6, 7, 8 networks. now that we have 8 networks, we can assign IP addresses to interfaces or our hosts. For example, let's say we want to assign IP addresses from this subnet. So the first usable IP address will be 136.11.64.1, and if we need to write subnet mask, we will write it 19. The last host which is usable IP address from this subnet, this one will be 136.11. What? Can you tell me? It will be 95.254/19. And you can ask me why? Because the next subnet after 64 will be 96.0, right? So one less than this will be the broadcast address for this network, which will be 95.255. But we cannot use this IP address to give it to host. So the host will be one less than this. So this one over here. Now you assign IP addresses from these networks. For example, from all of these networks, you only need 6. So you can assign IP addresses from these 6 different networks to different portions of your overall organization's needs. One important thing is that you cannot randomly assign IP addresses. For example, let's say we have an IP address of 22.22.22.22 with a subnet mask of 22. And we want to know that what is the subnet mask or the network, because obviously it's a class A network. You can straight away say that it's a class A network, and it should have a subnet mask of 8 by default, but it is having a subnet mask of 22. So we are doing subnetting, and we have borrowed 14 bits. We have borrowed 8 bits from the second octet and 6 bits from the third octet. So 8-bit means that the subnet mask would be 255.255 because all the bits will be in on position, while 6 bits would mean that we have 111.111.0.0 in the third octet, which would come out to be 252. So the example that we have seen earlier, that if we need to find out the step size, then for a second octet the step size would be 256 minus 255 is equal to 1, or we can say that with each number the network would change. But for third octet we will have 256 minus 252, which is 4, so a step size of 4. So it means that this network will belong to, let's say we write down the first network. So we write down 22. Let's say 22, because this will be a unique network. 23 will be a unique network. 24 will be a unique network, because we are seeing that we are doing all the bits for we are having all the bits for the subnets. So with every number we'll have a different network. So 22, 23 and it will be starting from 1. So 1, then 22 up till 255. And for third octet we will have 0 for our first one. Then what? Can you tell me? What will be the second subnet? It will be 4. Why? Because a step size of 4 in third octet. So step size of 4. And over here, let's just write 22. So for each 22 we'll have 0, 4, 8, then we'll have 12, and after that we will have 16, then 20, then 24. So this 22 falls in between 20 and 24 somewhere. So we will immediately come to know that this IP address belongs to a subnet which is 22.22.20.0/22. So what will be the first usable host from this subnet? It will be 22.22.20.1, right? And what will be the broadcast address? Can you tell me? It will be 23.255, because for 24 it will be a step size. If we consider this again, that if we add 4 into 20 we'll have 24, which will make it another network. So one less than that will be the broadcast address for this network, or rather this network 20.0. And the last usable host will be 23.255.4. So now you know complete range of the network and hosts of 22.22.22.22/22. Before I end this video, let me give you a small quiz, and you can answer that in comments if you like to. So let's say we have an IP address which is say 128.30.0.27 and subnet mask of 19. Now you need to answer me that which of these are the valid subnet addresses for this IP address. Now first option is 128.30.28.0/19. Can this be a valid subnet? I'm not talking about the host, I'm talking about the subnets. Let's say second one is 128.30. Let's say 48.0/19. Third one 128.30.160.0/19. And let's add another fourth option as well, say 128.30. Say 92.0/19. So either all of them or any of them or none of them, which of them are the valid subnets belonging to this IP address that we are seeing? So just revisit the last portion of the video and try to answer. I hope you have learned the concept of subnetting. Thank you for watching.